Hi all, welcome to sidza.com. Here in this video we will learn about the covalent bonding. In our last video we have learned that an ionic bond is formed by the transfer of electron. So that means in an ionic bond formation, when one atom it loses electron and the other one gains, so due to the transfer of electrons you get an ionic bond. But today we will discuss about covalent bond. How it is formed. A covalent bond is formed between the two atoms by the sharing of electrons, by the mutual sharing of electrons. So that means if you have an atom A and you got an atom B, and atom A provides one electron and atom B provides one electron, and now this electron pair becomes a common property, and you can say it belongs to the atom A and as well as the atom B. And due to the mutual sharing of electrons, a force of attraction develops between the two atoms, right? Due to this, sharing of electrons between the two atoms here, a force of attraction develops between the two atoms. That's called as a covalent bond. So covalent bond is actually a force of attraction that develops between the two atoms by mutual sharing of electrons. An ionic bond is a force of attraction that develops by the transfer of electron, right? So here is an example. If you look at it here, the chlorine has the 7 electrons in the valence shell. Another chlorine, again the same, it has 7 electrons. Now to get 8 electrons in the outermost shell, the two chlorine atoms, they can share this electron, okay? And now this is suppose the electron provided by the one chlorine atom, and this is the electron provided by the other one. Now this is the electron pair that belongs to this chlorine as well as this chlorine. And due to the mutual sharing, what happens? A force of attraction develops between the two atoms, which is called as a covalent bond. So covalent bond is formed by mutual sharing of electrons. To get a more detailed understanding of a covalent bond and the properties of the covalent molecules, we will discuss this covalent bonding in the three theories. Three important theories are there, and we will discuss all of these one by one. So we will discuss actually this covalent bonding under the three steps. Number one is the Lewis concept, Lewis theory. The second one is the valence bond theory, VBT, and third one the molecular orbital theory, MOT. So these are the three theories that which explain here the nature of a covalent bond. So let me start here with the Lewis concept, which is actually a very classical concept. Okay. According to the Lewis concept, it says that a covalent bond is formed between the two atoms by mutual sharing of electrons, right? Why this mutual sharing of electrons occurs? So as to complete their octet, right? It says that atoms actually share the electrons so as to complete their octet. Octet, which means that atoms want to attain 8 electrons in their outermost shell, or duplet, means 2 electrons in their outermost shell in case the element has only one shell, like hydrogen. So I'm going to explain it with certain examples. Let's take here again the same molecule, the chlorine molecule. You can see here chlorine has 7 electrons. It needs only one more electron in the outermost shell, and it will be a stable one, because if it has 8 electrons according to the Lewis concept, right, the atom becomes stable. Another chlorine atom, it also needs only one electron. So they will say, okay, we're going to share. Both the electrons are actually electron deficient, right? They're one electron deficient, and therefore they will share the electrons. Okay. So now this is the electron pair which is being shared. This chlorine has 6 here, and this electron also belongs to it. This electron pair belongs to it. So that means now this chlorine has got 8 electrons in the valence shell. So that means the octet of this chlorine atom is now complete. At the same time, you can see there are 6 electrons here, and this electron pair which is actually shared by the two atoms, again here for this chlorine atom, its octet is complete, right? So that's why a covalent bond is formed, to complete their octet or to complete their duplet in case the element has only one shell. So let's take another example. Oxygen atom, we know it has got atomic number 8, and electronic configuration, you can say it has 2 electrons in the first shell, and it has 6 electrons in the valence shell. Now 6 electrons in the valence shell for the oxygen, another one, the same thing, 2 and 6, So oxygen atom is deficient of 2 electrons. It needs 2 more electrons, right? It has 6, so to complete octet it needs 2 more electrons. Therefore the oxygen will share 2 electrons and in return it will get 2 electrons, right? So if the oxygen atom shares 2 electrons, another oxygen shares 2 electrons, now we have 2 electron pairs actually. These are the electron pairs that are being shared. And now this oxygen atom, you can see it has 4 electrons here, and now these are the 4 electrons which are being shared by the 2 atoms. So here the octet is complete, it has got 8 electrons in the valence shell, and this atom, it has got 8 electrons in the valence shell. Correct? So that means we have 2 electron pairs which are being shared by the 2 oxygen atoms. So that's why there's a double bond. One electron pair forms a one covalent bond. And if there are 2 electron pairs, they will form a double bond. So these are the non-bonding electrons here, right? The valence electrons which do not take part in the bonding. So that means oxygen has 2 non-bonding electrons. Okay? Non-bonding electrons. Or we also call them as, you can also call them as lone pairs. So oxygen has 2 lone pairs. This is one electron pair and this is another electron pair, right? Chlorine, if you look at here, chlorine has got, each chlorine atom has 3 non-bonding electron pairs, right? Each chlorine atom has 3 non-bonding electron pairs, or you can say each chlorine atom has 3 lone pair of electrons, and there's a one bond pair here. Correct? This will be called as a bond pair. Another example, nitrogen. Nitrogen atomic number is 7, and it has 2 electrons in the first shell, 5 electrons in the valence shell. So it needs 3 more electrons here. So electrons here. So nitrogen needs 3 more electrons. That's why the 2 nitrogen atoms, when they combine, they share the 3 electrons and they form a triple bond. There's a triple bond between the 2 nitrogen atoms because each nitrogen atom needs 3 electrons. So when they share the 3 electrons, right? So you get 3 electron pairs there. 3 bond pairs will be there. That means there will be a nitrogen-nitrogen triple bond, and it has only one non-bonding electron. Non-bonding electron pair. Or you can say it as a 1 electron pair there. And there are 3 bond pairs here, right? These are the 3 bond pairs. Let's take here an example of ammonia. Nitrogen, as we know that it is 3 electrons deficient, it needs 3 more electrons. Hydrogen here, it has 1 electron in the valence shell and it needs 1 more electron to complete its duplet, right? Because first shell can contain only 2 electrons, maximum 2 electrons. Hydrogen, it has atomic number 1, so it has 1 electron in the first shell. And we know that in the first shell you can accommodate maximum 2 electrons, so it needs 1 electron only. So that means the hydrogen will share 1 electron, nitrogen will share 1 electron. Now there is an electron pair between a nitrogen atom and the hydrogen atom. This electron pair belongs to the hydrogen as well as to the nitrogen. Same thing here, right? Same thing here. So nitrogen actually shares 3 electrons and each hydrogen atom shares 1 electron. So that means one nitrogen atom forms 3 single bonds there with the 3 hydrogen atoms. So in ammonia molecule there are 3 single bonds and there's a 1 non-bonding electron pair as a nitrogen. But at the same time, if you look at this Lewis concept, it doesn't explain much about the covalent bonding. It doesn't explain most of the properties of the covalent bonds, right? Suppose here this Lewis concept, it has certain limitations, like suppose it does not explain the stability of the molecules which have incomplete octet, right? Means the element in the central atom does not have 8 electrons. According to Lewis concept, atoms share the electrons so that they get 8 electrons in the outermost shell. Because if they get 8 electrons in the outermost shell, only then the molecule is stable. But we find that there are certain molecules, why do you find less than 8 electrons in the outermost shell? Let's take here an example of an AlCl3. Okay, AlCl3 is a very common example. We know that the aluminium atomic number is 13, and if you look at the aluminium, it has 2 electrons in the first shell 8 electrons in the second shell and 3 electrons in the third shell. The valence shell here for the aluminium is that it has 3 electrons in the valence shell. And AlCl3 molecule is a stable molecule, and here you can look at this for aluminium. It shares 3 electrons with the 3 chlorine atoms. Chlorine, as we know that there are 7 electrons, okay. Another chlorine, it has 7 electrons, and one chlorine atom can share 1 electron, which means that aluminium has how many electron pairs in its outermost shell? 6 electrons, right? There are 6 electrons for the aluminium. Okay, for the aluminium there are 6 electrons only. So its octet is not complete. Similarly, you will see certain other molecules also. The central atom does not have a complete octet. It has incomplete octet. It contains less than 8 electrons in the outermost shell. At the same time, we also find certain molecules with expanded octet, means they contain more than 8 electrons, right? They contain more than 8 electrons in the outermost shell. Let's take an example of, SF6. Very common example, sulfur hexafluoride. Sulfur atom, it has 6 electrons in the valence shell, right? It has 6 electrons in the outermost shell. So if you look at the sulfur, its atomic number is 16. Electronic configuration, you can say 2, 8 and 6. So it has 6 electrons in the outermost shell. And in the SF6 molecule, one sulfur atom is attached with 6 fluorine atoms through 6 covalent bonds, single bonds there. Okay. So SF6 molecule here, it shares how many electrons? 6 electrons with the 6 fluorine atoms. Okay. So that means it has got how many electron pairs in its outermost shell? For the sulfur, it will be 12 electrons, right? It will be 12 electrons. So for the sulfur here, it has got 8 electrons in the outermost shell, right? Here for the sulfur, it has, you can say, 8 electrons in the outermost shell. So that means Lewis concept cannot explain the stability of a molecule that contains more than 8 electrons in the outermost shell. So expanded octet. One more drawback with the Lewis concept is that it cannot explain the shape, right? It doesn't explain the shape. Suppose we know that for a methane molecule CH4 carbon, it has 4 electrons in the valence shell, and hydrogen atom, it will provide 1 electron, another hydrogen. Okay. We know that the methane molecule actually its shape is tetrahedral. But why the shape is tetrahedral? Lewis concept has no answer. It does not explain us the shape of a molecule. How we can determine actually the shape of a molecule. So we do not get this kind of information from the Lewis concept. Hope you got the concept. Thanks for watching the video. Bye for now.